Okay, so this is your measurement test review for Unit 1 test. That is going to be on the 29th and, 26th and 29th. So a red day and blue day. Be careful, blue day, because your test is on a Monday. All right, so this first page, front and back, is just a checklist of everything that you need to know to do well on the test. Okay, so you should go through these and be able to either use this on the review or be able to answer questions about each one of these things. Okay, if not, look at a video, come talk to me, but you got to do something before your test day. Okay, so your actual questions start on page 13. So part A here, this is all found directly in your notes on page 1. Okay, so we're going to start number 6 here. So you're just placing these in order from increasing to decreasing. All right, so you're going from smallest to largest. Okay, smallest to largest. So when we look at all of these prefixes, they can go with meter, liter, gram, but they all mean a certain number. All right, so if your base unit is here, your base unit like liters, grams, meters, so the smallest is going to be milli, your next will be centi, and then your next should be deci. All right, then you have your base. After your base, so we have milli, deci, centi gone, it should be deca, hecto, and then kilo. All right, so this is King Henry died unusually or by drinking chocolate milk. Okay, so if you did it like we did it in class, King Henry died unusually or by drinking chocolate milk, you're increasing from the bottom to the top. Okay, part B, this got a lot of people. I'm really worried about these two steps here, so I'll do one of them for you and then show you how it should be done. All right, so if I wanted to change 2,000 milligrams into grams, my work might start like this. I know milligrams needs to be changed from milligrams into grams. We practiced that extensively in class because milligrams will cross out with milligrams. So what equality do I need to put for my conversion factor to figure this out? Well, if I go back up here to what I did in this, in number 6, I'm going from milligram into gram. All right, so my equality is, well, milli is down here, gram is my base, so it takes 1, 2, 3 to get to my base. So I know that gram is my bigger unit, so the 1's going to go there, and the 1,000, 3 zeros, because 1, 2, 3, that's where those 3 zeros came from. So I know that every 1 gram equals 1,000 milligram. All right, there's your equality. Now, and here's the work for it. All right, and so what you should be able to see is that because there's 3 and we're dividing, we should be able to move that decimal 3 spots to the left, and this will just be 2 grams. All right, so here's your equality, here's your work, and then there's your answer. And that's how you do each one of these 4. All right, so circle the conversion factor in problem 7. Here's your conversion factor, and then box the 2 conversion factors in number 8. Now, when you do your work over here, we've learned how to do all these in one step. So instead of 2, you can just do the 1 conversion factor like we did in 7. Okay? If we look on the back side here, graduated cylinder, and circle the estimated digit. So remember, your estimated digit is always your last digit in any measurement. Okay, so if we look at, let's say, some of these are kind of hard to read, but let's look at number 8, and it looks like the meniscus falls right on that line. So these are all going to be measured in milliliters because it's volume. That's what graduated cylinders measure. So we have 4, 5, and there's 6. All right, which means each line in between here is going to be 0.1 milliliters. So 1, 2, 3, 4, 5, 6. It looks like it lands right on that 0.6 mark. So if I say that my best estimated measurement is 5.6, that's going to be wrong because it lands right on that 6. That's not an estimated value, right? We always have to have one more digit for an estimation. So this should be, because it lands right on the 6, it should be 0. And there's my estimated digit. Now, if you put a 1 there, or if you put something very close to this, that's fine. Just make sure you circle your last digit. All right. If you only have 2 digits for each one of these, that's wrong because you didn't give me an estimated spot. All right. C, scientific notation. So number 14 here, because this is a decimal, I know that this is going to be 10 to the negative power of something. So how many times do I need to move this decimal to get it with only 1 digit in my ones place? 1, 2, 3, 4, 5. I moved it 5 times, so it should be to the negative 5th. My new number is 7.86. Okay. Down here, rewrite each number in standard notation. Okay. So we're just kind of undoing what we did up here. So this is 6.17 times 10 to the third, because that's not, if it were negative, we'd move it to the left, but because it's positive, we're going to move it to the right 3 times. 1, 2, 3. And now this empty space is going to be a 0. So my answer is 6170. Okay. Down here, sig figs, let me do 31 is a good one. It kind of has all the rules to it. Okay. So first off, we have 3 non-zeros, right? Then we have 2 zeros that are sandwiched, right? Then we have these trailing zeros to worry about, and because here's your decimal, they are your final zeros after the decimal. Each one of those also gets counted. So there's 1, 2, 3, 4, 5, 6, 7 sig figs there. All of them will be significant. If we look at 33, well, there's 2 non-zeros, and then we have all these other zeros, right? So are these front 3 sandwiched? They are not, okay? These are all placeholders, right? And they're not, these 2 zeros are not final zeros after your decimal. So the only 0 that counts is this trailing final 0 after the decimal. So you should only have 3 sig figs there, okay? If we go to the last page, calculate and significant figures, perform the following calculations, report your answers with the correct sig figs and or decimal places. All right, so we're going to do this into our calculator and then write out the sig fig amounts and put it in scientific notation. Okay, so if I take 0.21 my calculator divided by 31 point 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then if I put this into scientific notation, it's going to end up being 6.77. Now, because we need to use sig figs, I know that all of these are significant, so that's a large number. This is where I'm going to probably find the least amount. So in this case, there's only 2 sig figs. So already, this is not a correct answer because there's 1 sig fig, there's my second. That 7 is going to round up that 8. So my answer should be 6.8. And then for my calculator, it took me 1, 2, 3, 10 to the negative third, because these are decimal numbers, and there is your answer. Okay, so when you put in scientific notation, and it needs to be in the correct sig fig amounts. Okay, if we go down here to accuracy and precision, this is just, you can look at these in your notes, but accuracy is how close to the given amount. Precision, is it repeatable? That's what you're answering when you answer these questions here. All right, we'll go down to percent error. All right, here's your formula, and remember that this formula is a absolute value. Okay, in an experiment, the gram atomic mass of magnesium was determined to be compared to the accepted value of that. What is the percent air? So accepted value is 23.7. Well, that goes first. And then I subtract what was measured in the lab, which was 25.3. And it looks like we're a little bit over what it should have been. And that's okay to have. That can happen in a lab. And then I divide all of that by the accepted value, which is 23.7. So when I go to my calculator and do that, make sure you do that first. 23.7 minus 25.3, negative, and that's okay. And then divide it by 23.7. And we get 0.0675 negative. Now, because this is absolute value, when I multiply this by 100, okay, my percent air is now not negative, but just 6.75. And I have 3 sig figs everywhere, and so there is my answer. Okay. Down here at dimensional analysis, I'm going to do number 45 because this might be the harder of the group. All right. So it's the same process of what we're doing. We have to have a given. We need to know what we're getting into, and we have to know how to get there. Well, these are all of the things of how we're going to get there. So the given are contained in 100 grams of iron. So 100.0, that 0.0 is important, grams of iron. Okay, and I need to turn that into atoms of iron. Well, here's all my conversion factors I need to use. I know that in 1 mole of iron, which is right here, there's 55.845 grams of iron, which is this conversion factor here, this equality. So grams of iron cancels out, and I'm left in moles of iron. Even though you don't really know what moles of iron are yet, it tells you exactly what you need to know to convert. You don't need to know what a mole is right now to convert this. So then I know my next equality is here. Moles of iron need to go here so that they cancel out. And moles of iron can equal 6.02 times 10, and that should be not 23 but 10 to the 23rd power. 10 to the 23rd. And now we're left in atoms of iron. Okay, so when I go to my calculator, make sure you keep that all together. Should be 100 times 6.02 times 10 to the 23rd divided by 55.845, and I get with sig figs, there's 4 sig figs, so I need 4 sig figs for my answer. 1.078, because that 9 will round up that 7 to an 8, times 10. In my calculator, that E is times 10. 10 to the 24th. And there's your answer. Okay, so that's what you need to do, is be able to plug in any conversion factors to this dimensional analysis and come up with the right sig fig answer. And this should be, I'm missing my units, atoms of iron. There we go. Okay, so I hope that was helpful for your review.